to list the terms. So first you start with 1, 1 minus 3, 1 plus 2. Then 2 plus, the sum says plus. 2 minus 3, 2 plus 2, and then plus. When k is 3, 3 minus 3, 3 plus 2, and plus the last term when k is 4, and we get this. Yes, you can calculate it with the graphing calculator. And you go to math, and you scroll up, and you see 0 is the summation notation, or sigma. And then we don't have I, K, J in the calculator, so from 1 to 4. And we have parentheses, x minus 3, and x plus 2. And you click enter, and you get the whole answer, which is -4. Easy to calculate, there are only 4 terms, but you can use the calculator if you don't want to do the arithmetic. Any questions on this? Anybody? Any questions?
I don't have anything.
Okay, so then we go to the other one, which was, I think you said 47. Very good. So in 47, you said 47, yes. 1, it was 47, right? Did I?
Yes.
Yes, okay, perfect. So we have 1 plus 2 plus 3 plus dot 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 plus 30. Good. So for now, can anyone, so let's say use I, we use I this time. What is the first term and what is the last term?
The first term is 1 and the last is 30.
Yes, the lower limit is 1 and 30. So what should I have here? So that when I is 1, I get 1. When I is 2, I get 2. When I is 3, I get 3. When I is 4, I get 4. What will be the general term? So that when indeed, that's it. When I is 1, plus when I is 2, plus when I is 3, plus dot 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 when I is 30. Excellent. Good. It doesn't mean that we cannot go back to those. I just wanted to say that we looked at some problems.
Factorials.
Good. Here they are. Here they are, the factorials. Any? Any problem?
26.
Okay, very good. And 26, we have 20 factorial over 2 factorial times 18 factorial. So always try to simplify, because the calculator may not have enough space or memory, in other words, to calculate. So this is an easy problem because I have 20, 19, and 18 factorial. Why do I stop at 18? Because I see 18 at the bottom. And this is a 2, and times 18 factorial, and they go away. I simplify, and I get 190. So always remember, simplification is is the best route, always, if it's possible. Anything else? Is there anything else you would like to work on, or can we start reviewing for the final?
Can we just finish up with the sequences and then the non-linear equations?
Good. So let's look at sequences. Okay, here they are from 1 through 18. One through 18 for the sequences.
Can we do 11 and then 17?
Sure. 11 and 17. And in 11 we have -1 to n plus 1 over 2 to the n minus 1. This one I remember doing. They won the first 4 terms. So a1, 1 plus 1 is 2. So -1 to the second power is 1. 2 minus 1 is 1, so the first one is 1. And then a2, 2 plus 1 is 3, so -1 over, 2 to the second power is 4 minus 1 is 3. Good. A3 or a sub 3, 3 minus 1, 3 plus 1 is 4, so we have 1 over. 2 to the third is 8, 8 minus 1 is 7. And the last one, -1 over 16 minus 1, which is 15. So the first 4 terms of this sequence are 1, -1/3, 1/7, -1 over 15. Is this okay, everyone?
Yes.
Okay, perfect. And 17. 17. So a1 is 4. And a sub n equals 2 a sub n minus 1 plus 3. Of course, for n greater than or equal to 2, because we already have n sub 1. A sub 1. Good. So, the second term, a2, is 2 times the previous term plus 3. A sub 3 is 2 times the previous term plus 3. 22 plus 3, 25. The fourth term is 2 times the previous term plus 3, 53. 2 times 25 is 50, 50 plus 3 is 53. And the nonlinear, they are in 5.2, I believe. We'll see in a moment. Am I logged out or, oh, no. 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 Good. System allow linear equations into variables. Good. We're ready?
Can we do 16?
Yes, 16. Where are you? 16. Good. So we have x plus y equals -3, and x squared plus 2y squared equals 12y plus 18. Good. Notice that the variables are not the same. So what is my only option here? If the variables are not the same. What is our only option? When variables are...
The first one and substitute.
Exactly. There is no other way. You choose. It doesn't matter in this case, either x or y.
Can we solve for x?
Good. So -y minus 3. Careful because it's negative and negative. Okay, so I have to plug it in here. So that was a good choice. Solving for y, I would have had to replace it here and here. But because we solved for x, I only have one replacement to make. It was a very good decision. So -y minus 3, everything squared, plus 2y squared minus 12y minus 18 equals 0. I know it's going to be quadratic, so I have to set it equal to 0 anyway. Now, careful here because I have to have 3 terms. Now, because both terms are negative, everything will be positive. Here's why. You can rewrite it by factoring out -1, -y, -3 squared. But when you square -1, you get 1. So this is the same with y plus 3, everything squared. So then, when I square the first term squared plus 2 times the first times the second, plus the second term squared. And then I copy the rest, plus 2y squared minus 12y minus 18 equals 0. Now I have to clean it up. So let's clean it up. Y squared plus 2y squared, 3y squared, 6y minus 12y, -6y, 9 minus 18, -9 equals 0. Of course, I'm going to continue cleaning it up because I notice that all 3 terms can be divided by 3. So I have y squared minus 2y minus 3 equals 0, and this is not difficult to factor. Into y minus 3 and y plus 1. So I have 2 options, y equals 3 and y equals -1. Is this good? Yes, but not good enough because I only have y. But that's okay. If y is 3, -3 minus 3, x equals -6. If y is -1, 1 minus 3 is -2. So we claim 2 ordered pairs as solutions. We claim -6, 3, and we claim -2, -1. Do they work? I don't know. So negative 6, 3 first. Yeah, this is okay. So negative 6, 3, 3. Negative 6 squared is 36. 3 squared is 9. 9 times 2 is 18. So this should be 54. 3 times 12, 36. Plus 18, indeed 54. So I will say the first one, yes. And then I check the second one. Negative 2, negative 1. Yes. Negative 2, negative 1, negative 1. So 4 plus 2 is 6. Negative 12 plus 18 is also 6. So I will say yes to both. But I will definitely always, always, always check. Any questions? Okay, please tell me what you would like to do next. Please, anybody?
I think I'm ready to start reviewing for the final if everybody else is.
Good. Okay, so we reviewed for test 5, that is done. I think we should go back to test 4 and review again the exponentials and log. Is that okay?
It's fine with me.
Okay, perfect. So back to the book. Oh, I didn't mean that. So we finished 5, 6, and 8, and now we go back to chapter 4, which is exponentials and log. Okay. So maybe we should start with word problems or equations. Which one would you like to start with? These are the equations of exponential and a log, and this is word problems. And this is logarithmic properties of logs. And these are the graphs. So what would you like to start with? Word problems, equations, properties of log, condensing and expanding. Any preference?
I'm good with word problems.
You want to start with the word problems?
Yeah.
Okay, perfect. Okay. Logistic growth model. We see it from the calculator screen at the bottom of the previous page, they say. We see here, there is a relationship. They're giving us an equation. Okay, fine. And it says, the logistic growth model for world population f of x in billions x years after 1949, correct, So I immediately make myself a note. X equals 0 means 1949 is given as f of x equals 10.95. Everything divided by 1 plus 3.51 e to negative 0.029x. Okay. Solve exercises 38 through 42 using this function. How well does the function model the data showing a world population of 7.5 billion for 2020? So they claim that for 2020, the population was 7.5 billion. And they're asking us, do you think that the model does a good job on that piece of information or not? How will I know? What should I do to check that the model is good for 2020, showing us 7.5 billion or close enough? What should I do? What should I do to verify that I will get 7.5 billion if I calculate the population in 2020? Anyone, please? What do you think? What should we do? How will I verify that in 2020 the model gives 7.5 billion?
Would we find f of 0?
0 has nothing to do with this. We need to determine f of 2020 when x is the difference between 1949 and 2020.
Would you say x as 71?
Yes, exactly. So I have to find f of 71 because that's what I am interested in determining for the year 2020, but I cannot plug in 2020 in a model because it says x is not the name of the year. X is years after 1949, indeed. So I plug in 71, and if I get close to 7.5 billion, I'll say, yeah, the model appears to be okay. So you know what I'm going to do, because I don't want to do this by hand, and I may need it to do it more than once. So give me 1 second to clear this and turn it off. Okay. So I go to y equals and I put the function in. 10.95 divided by, in parentheses, 1 plus 3.51 e, and the power is negative 0.0, I think 0.029x. Close, and then close the denominator. And then I go to second and table, and I put in 71. Yeah, okay. So the actual answer, they say 7.5. And look here, 7.56. It's extremely good. 7.56 billion. Good. Thank you. Let's go to the next question. How well does the function model the data showing a world population of 6.9 billion for 2010? So what do I do now to check what happens in 2010 or what happened in 2010? Instead of 71, I plug in 61. That's why look how handy it is, the fact that I put in the function. All I have to do is punch in 61. And I get 6.85. So I go to, so 6.85 and 6.9 is still very good. When did world population reach 7 billion or 8 billion? We're going to do one of these. According to the model, what is the limiting size of the population? In other words, that's very easy. It's always the numerator. But how will I know? Just increase the number of years. Let's say, so 71, 61, let's say 90 years later. Let's say 100 years later. Let's say 200 years later. I have to get to that 10.95. Okay, 500 years later, 10.95. 600 years later, 10.95. 700 years later, 10.95. It's always the numerator for such a function. But how will I determine when did world population reach 7 billion? Or 8 billion, one or the other. So I'm asked when 8 billion people exist. When did it start? So what do I need to do now? To determine when.